Okay, we are going to try to solve all the calculator required portion of this mock AP Calc AB exam. Once again, this is given by Lucid Education. I have no idea if this was a real exam or not, but let's do this calculator required portion. Okay, number 76. The derivative of function f is given by f prime is this guy. At what values of x does the graph of f have a point of inflection or an inflection point? Okay, so point of inflection, that should signal second derivative. So I found it by hand. That's what I did here. You just do quotient rule, bottom d top minus top d bottom over bottom squared. Okay, if you have like a TI-84 or something like that, you can put this as y1 and y2 is n derived y1, something like that if I remember correctly. Instead of typing all this, finding this by hand and typing all this in. But my graphing calculator app on my phone, I don't have that n derived function, or I couldn't find it. Maybe it's because I have the free version, but so I found this by hand and I put this in the calculator. Okay, so let me show that. Okay, so the graph looks something like this. Oh, let me pan it a little bit. Okay, so point of inflection, that's when the second derivative changes sign. So where does it change sign? It changes sign at this point, so let's find the root. That's 0.382 around there, right? And then also here at 2.618 around there, right? So it doesn't list the 2.618, but it does list this point, so B. Whoops, B. Region in the xy plane bounded by the lines x is 1, x is 3, y is 2, y is log x is the base of a solid. Each cross-section of the solid perpendicular to the x-axis is a square. Volume of the solid is, this is a classic problem. So how does this region look? Log x looks like this guy over here. All right, y is 2 is somewhere here, so you can even use your graphing calculator to help you get this region. Okay, y is 2 somewhere here. X is 1, x is 3. Those are just two vertical lines. Okay, so I lightly shaded the region. So cross-section perpendicular to the x-axis is a square, so I drew a representative square perpendicular to the x-axis. The side of the square I labeled as s. What's the length of s? That is just 2. Yeah, 2 minus log x. Actually, I even sketched this region wrong, but okay. So let me re-sketch it. Or actually, let me just show it on my calculator. I have it already. Okay. So log x is here. X is 2 is here, so ignore this. Okay, so the region is from x is 1 to x is 3. So here's this vertical line here and a vertical line here. So the region is up here. Okay, hopefully you can see that. I can't shade it because it's my phone, but hopefully you can see that, okay? So the length of, again, if I draw a representative square, it'll be like that. The length is 2 minus log x. That's the length of the side of the square. Okay, so the volume is integral of side squared dx, because each area of the cross-section is a square, so the area of squared is side squared, and then it has a small width dx, so side squared dx, we integrate all of them. Okay, so it's integral from 1 to 3, because that's our limits of integration. 1 to 3, because our region is bound up in terms of x by 1 and 3, of 2 minus log x squared dx. Plug this into your calculator, you should get 3.8458. That's choice A. So apologize for the incorrect sketch, but luckily you use a calculator for this problem, so you can just do that. Okay. Function f is differentiable. F of 3 is 6, f prime of 3 is 4. Function g is defined as g of x is f of x over x. Equation of the tangent line to the function g at x is 3. So to get the slope of the tangent line, we need the derivative. So g prime is, we need quotient rule. Bottom d top minus top d bottom over bottom squared. That's what I did here. So g prime of 3 is, we just plug in x is 3, f prime of 3, they give us as 4, minus f of 3, they give us as 6, over 3 squared, which is 9. So that's 6 over 9, which is 2/3. That's our slope. We need a point. X is 3. What's the y coordinate? So that's g of 3. So that's just f of 3, which is 6, over x, which is 3, which is 2. So y minus 2 is 2/3, x minus 3, the point slope form. And that is, looks like choice D. Okay. Which the following could be a graph of f such that this integral, and then times 1 over 3 minus 1, is equal to 2. Okay. So this is the same thing as half, right? So I just move this half over to this side, so I'll multiply by 2 on both sides. So integral from 1 to 3, f of x dx is 2 times 2, because I'm, again, multiply by 2 on both sides, which is 4. Okay? So we want the area under the curve to be 4. Okay? So I just took the easiest cases first. Well, here we know that it looks circular, but if it was a circle of radius 3, it looks something like this, but there's some there's an extra rectangle. But either way, it'll be in terms of pi, which clearly it's not, so we can eliminate that. And this one will probably be some non-nice number, so it's probably not that, but let's leave it alone. We can look at the other choices. What's the area under the curve of this guy? That's just a rectangle of base 3, height 1. So 3 times 1, which is 3. 9 equals to 4, cross out. Here, it's a trapezoid, right? So average the bases times height. This base is 1, this base is 4. We average it times the height, which is 2. So this is equal to 5. Again, which is 9 equals 4. Cross that out. Lastly, over here, you can add this triangle and this rectangle. So triangle is half the base times the height. Half times the base is 2. The height is also 2. The area of this rectangle here is 2 times 1. So this is equal to, this is 4 divided by 2, which is 2 plus 2, which is 4, right? And that matches our answer. So it's this. We don't even have to check this one. But as I said, since it's a parabola, it won't be like some nice number, probably. Acceleration of a particle moving along the x-axis is given by the sky. At time t is 2, velocity of the particle is 2. What is the velocity at time t is 3? So immediately, without even looking at my answer, you should already think, well, integral of acceleration is velocity. So we could, in theory, find the antiderivative of this. We have an initial condition when t is 2, v is 2, and use that initial condition to find that plus c. And then that would be, we can find a particular solution and then plug in t is 3 to get our final answer. But this we can't integrate by hand. So we need to think of a different way. We can use a definite integral. So the idea that integral of acceleration is velocity is still correct. Okay, so we're going to use a definite integral though. Integral from 2 to 3, a of t dt. That's just by fundamental theorem calculus, v of 3 minus v of 2. Because once again, integral of acceleration is velocity, or the antiderivative of acceleration is velocity. Okay, so v of 3 is, just rearrange terms, v of 2 plus integral 2 to 3 a of t dt. But they give us v of 2, right? It's 2. This you can put into your calculator. It's a definite integral, so your calculator can find it. That's 2.872. So the answer is 4.872, which is D. Shown are selected values for functions f, g, h, j, k, all which are twice differentiable in a closed interval 1 to 4. Which of the functions has a negative first derivative, positive second derivative? Okay, so this is very similar to the last few problems we did in the no calculator portion. When it's a negative first derivative, that means the function is decreasing. So we can already eliminate these two because our functions are increasing. Everything else, it looks like it's decreasing, right? Now, positive second derivative, that means our function is concave up. What does concave up mean? That means the rate of change is increasing. Okay? One more time. Derivative is rate of change. So the rate of change, that rate of change, so the rate of change of the rate of change is increasing. Okay? So that means when it's okay, we can even sketch it out, for example, if that helps you visualize it. Decreasing and concave up looks something like this. Okay, so since I said that the rate of change, concave up, that means the rate of change of the rate of change is increasing. Since our rate of change was negative, it's going to get less negative, which means, which you can see that here, right? The slope of the tangent line is getting less negative. Okay, now, here you see that it's a constant minus 2. So the rate of change is constant. So it's not changing. So that's false. So that's, we can cross that out. Now over here, the rate of change, so this is minus 1, minus 2, minus 4. So it's, does it follow this shape? It actually is decreasing faster, right? Well, over here, we said it's decreasing slower. So it's not B, we're left with C. And you can see that this is minus 3, minus 2, minus 1. So the rate of decrease is decreasing, as we were saying. 81C. Okay, let's move on. Particle is moving such that its velocity is given by here. Acceleration of the particle when t is 3. Acceleration is the derivative of velocity, so we want v prime of 3. So you can just plug it into your calculator, but I found it by hand. 2.5 cosine of, I found the derivative by hand, and then we need to plug in t is 3 into a calculator still. Okay, so derivative of v is, derivative 2 is just 0. Derivative here is 2.5 cosine of 0.6t times 0.6. Okay, so we evaluate t is equal to 3, and that is minus 0.341-ish, right? So that's A. Okay, if you have the graphing calculator, you could put this as y1, y2 is n derivative of y1. That's what we're doing over here. And then we evaluate y2 at 3, and then you should get that. Function f is defined as here, for x between 0 and 3.8. On what interval is f decreasing? F is decreasing when the derivative is negative. So we want f prime to be negative. What's f prime? Fundamental theorem of calculus. It's cosine of x squared over 2 times derivative of x, which is just 1. Okay, so we want this to be less than 0. So let's graph this guy and see where it's less than 0. Okay, so x is between 0 and 3.8. So pi is 3.14 something, so it'll be a little more than that. Okay, so my app is giving it in terms of pi, so that's why I said that. Okay, so it'll be a little after pi. All right, we're interested in when f prime is negative. So where's f prime negative? It's between this point and this point. So we're going to find roots. This x is 1.77, and then this x over here is 3.07-ish. Okay, so that's when f prime is negative, which is when f is decreasing. So that's this answer. Okay, moving on. These are related rates. Circle's radius is increasing at a constant rate of 0.3 meters per second. What's the rate of change of the area of the circle when the circle's circumference is 6 meters? So as always, I like to write in variables what we know and don't know. So they give us dr dt, the rate at which the radius is increasing, is 0.3. They're asking us the rate of change of the area, so dA dt is question mark. Circumference is 6 pi. Okay, so ignore that for now. We want dA dt, so what's the area formula for a circle? A is pi r squared. Let's differentiate this. dA dt is 2 pi r dr dt. We have dr dt, we don't have r, so that's when the circumference comes in hand. Circumference is 2 pi r, so r is equal to 3 when we solve for r. Okay, so now we have r, we have dr dt, we can find dA dt. So I just plugged in, so this is 1.8 pi. Function f is continuous on this closed interval, -1 to 3, and differentiable on the open interval, -1 to 3. If f of -1 is 1, f of 3 is 1, which the following statements must be true. Okay, so this is probably testing you on mean value theorem, intermediate value theorem, all that kind of stuff. Okay, so let's, since I did this problem before, let's pick out A and C first. This talks about f of c being some value. So what does intermediate value theorem say? So it's continuous on this interval, -1 to 3, that's critical. Since it's continuous, let me even sketch. F of -1 is 1, f of 3 is 3, okay? Since it's continuous, it has to cross like values, all values in between. So there will be some value between x is -1 and x is -3, some value of x such that that value at x would be, for example, 2 or even half. Okay? Actually, not half, sorry. 1, 2, or 3 halves. 1.5, 2, 2.5, 2.75, 2.9, doesn't matter. Since it's between 1 and 3, one more time, I'm going to say it one more time, by the intermediate value theorem, it has to cross all points between 1 and 3 at least once within this interval. So for example, one more time, 2 is between 1 and 3, right? So since it's continuous, it has to cross 2 eventually at least one time to get to this point. It can just go in a straight line. It can go up and then down and then up and then there, something like that. So it just has to cross at least once. So what can f be half in this interval? It could be, but we don't know. This must be true. Okay, we don't know if it goes down to half. Half is here actually, so I'm exaggerating, but we don't know if it goes down and then up. Okay, because once again, the theorem says only for the values between 1 and 3, we are guaranteed that it will cross that value at least once. Half is not within 1 and 3, so we can cross that out. Similarly, 0 is not between 1 and 3, the y values, so cross that out. Okay? Now, what does mean value theorem say? It says that between -1 and 3, it meets the conditions that it's differentiable and continuous, okay? Mean value theorem says between these 2 points, there will be some number c such that f prime of c is the average rate of change, which is what I found over here. The average rate of change is half. So there will be some f prime of c such that it's equal to half. That's choice E, actually. Okay, by the mean value theorem. Okay, now, it can't guarantee that, so it could guarantee it because we just applied the mean value theorem, but cannot guarantee 0. We don't know anything. Okay, only the average rate of change we can guarantee by the mean value theorem. Now, what does this say? X is number c such that f of c is greater than equal to f of x for all x. This is saying that there's going to be a absolute max there, something like that. We don't know if that's true or not. Okay, we don't know what happens in between. It could just be in a straight line. There won't be an absolute max, right? For some value in between 1 and 3. So the absolute max would be here. Okay, hopefully that makes sense. Let's move on. For which graphs does limit as x approaches 3 f of x exist? Limit from the left, from the right are the same, so this is good. Limit from the left does not equal limit from the right, so not good. Limit from the left equals limit from the right, so the limit exists. Okay, it's not continuous at that point, but the limit exists. Okay, so it's 1 and 3, so choice E. F prime is cosine 2x. How many relative extrema does f of x have on this interval? Okay, so you can graph this, and this is a very bad sketch, but I sketched it. It should look more like this or something like that, okay? But anyway, this sketch gets the point. Relative extrema, that is when there's a relative max and min. Okay, that happens when f prime changes sign. So between pi over 2 and 2 pi, how many times, this is f prime by the way, how many times does f prime change sign? Happens here once, happens here twice, happens here thrice. Answer is B. Okay, we have about 5 more, so let's move a little quicker. Let's see if we can. Remote control helicopter is launched. During the first 6 seconds of flight, the rate of change of the helicopter's altitude is given by this guy. Which of the following expressions represents the helicopter's change in altitude during the time that the altitude is increasing? Okay, so there's 2 parts to this in my mind. We have to first find when the altitude is increasing. Okay, how do we do that? This guy is the rate of change of the helicopter's altitude. So if the rate of change is positive, that means the altitude is increasing. Okay, so we want when r of t, the rate of change, is positive, as I just said here. Okay, I wrote it in words. So let's graph this guy, and I already have it here. It's positive. By the way, we don't care when t is less than 0 because that's negative time, so we're going to look only when t is greater than 0. Okay, we want r of t to be greater than 0, so that's right here. That's between, what's this point? 1.515. And what's this point? That is 4.626. That's what I wrote here. Okay? So we want to see within this time when the altitude is increasing, how much the altitude actually increased. So we just integrate, because remember, integral, definite integral, is net change. So the integral from time 1 to time 2 of RT dt is the net change in altitude from T1 to T2. So we found when the altitude is increasing, so we just plug in T1 as 1.515, T2 as 4.626. So that is not r prime. It will be this one. I'm like, why do I not see the answer? This one. Not r prime. This is r. We're going to use r. Because r is already the rate of change. Okay. Potato is baked at a temp of 400 degrees Fahrenheit. Time t is 0, it is taken out of the oven and allowed to cool in a 72-degree Fahrenheit room. Rate of change of the potato's temperature is given by the equation in the sky, where t is the time it emits. What is the potato's temperature to the nearest degree after it has cooled for 4 minutes? Okay, so this is making a critical assumption that once the potato leaves the oven, it starts at a temperature of 400. It's not quite clear in this problem, but that's what it's assuming. Actually, this 72-degree Fahrenheit room is not relevant, so don't be fooled by that. Okay, so once again, we're going to kind of what we did up here. If we integrate from 0 to 4 RT dt, that is what? Since this R is the rate of change of the potato's temperature, when we integrate a rate, we get the net change. So it's the net change in temperature from T is 0 to T is 4. Okay, and as I said, at T is 0, the temperature is 400. So after 4 minutes, the temperature would be the initial 400 plus integral from 0 to 4 RT dt. Okay, so we get 400 minus 207, because this you plug into your calculator. Yeah, your R here, so you just plug this into your calculator, you get around negative 207. So 400 minus 207, that's 193. Okay, if you use the initial condition that it's 72, you get 72 minus 207, which is a negative number, which clearly you don't see in the answer, so you know you did something wrong. Okay, so it assumes that it starts at 400, okay, and then we add the net change, which is a negative number. We expected it, because as it's cooling, the net change in temperature it's dropping, so it'll be a negative, okay? That's how we do that. And by the way, it's not C, because that's, once again, that's the net change after it gets out of the temperature. The potato originally had an initial temperature of 400, so we got to consider that. If it started from 0 and it grows, the temperature is increasing, then that would be right, but this is not used in the context of the problem. That wouldn't be correct. Okay, let's move faster. 3 more. Let's see if I can move faster. It's already 24 minutes. The integral 0 to 5 g of x dx is under approximated by a trapezoid sum over approximated by a left Riemann sum, which the following could be a graph of g. Okay, so let's just draw a rectangle by left Riemann sum to see which ones are overestimates, and we keep those, and underestimates we cross out. Okay, so if we draw a rectangle like here, clearly that's an overestimate, so we keep that. We draw a rectangle here, left endpoint, underestimate, cross this choice out. Here, draw a rectangle with the left endpoint, again, underestimate, cross out. Here, overestimate, keep. Here, also overestimate, keep. Now let's draw a trapezoid. Okay, so here, if we draw a trapezoid, it'll be exact actually. So in fact, you can even, this is a trapezoid. So it'll be the exact, so it won't be a underestimate, it'll be exact actually. So cross that out. Draw a trapezoid here. This is, you might not see it with my thick pencil, but hopefully you can kind of see it's an overestimate here if I draw the trapezoid there. Okay, so it's not this one either. So we're left with E. And we can even draw the trapezoid here. Here's the base. It'll be like this. And you can kind of see it's an underestimate, hopefully on screen. Okay, let's move on. Object is moving along the x-axis such that its velocity is given by this guy. Average velocity of the object from t is 0 to t is 4. We just used the average value formula. 1 over 4 minus 0, that's the time interval. Integral from 0 to 4, again, that's the time interval, v t dt. Plug this in your calculator, you get this guy. Okay, so we are moving a little faster. Now last problem, let's see how long this takes. Graph of function f on interval -1 to 4 is shown. Regions A, B, C have areas of 1, 2, 3 respectively. What's this integral? Okay, so we're going to use properties of integrals to break this up into integral from -1 to 4, f of x dx plus integral from -1 to 4, 2 dx. Properties of integrals. Okay, this integral is area under the curve. So we're going to add, so this area is 1. This area, they tell it is 2, but it's below the x-axis, so we're going to put a minus sign. -2, this is 3, so plus 3. And then this is just 2 times 4 minus -1. Okay, this would be a rectangle, or you can do fundamental linear calculus, and that's fine too. Okay, so this is what? 4 minus 2, which is 2. This is 2 times 5, so the answer is 10 plus 2, which is 12. Okay, and that's it for this calculator required portion. Wasn't too bad, right? So hopefully this was helpful if you got stuck on any of the problems or needed just an explanation of how I personally would approach it. Okay, please like this video if you found it helpful, as always. And also, as always, please subscribe to the channel if you like this type of video and want to see more, because I do have a few more problems that, sample exams, mock exams that I have on hand. So I can definitely do them if you like these types of videos. So I'll see you in the next video that I make.